So we're starting to get into quadratics. We're going to need to factor the quadratics before we can find the solutions. So today's lesson is finding out what does x equal. What are my two answers for my quadratic? So standard form. First off, on this paper you've got standard form. ax squared plus bx plus c equals 0. That's just meaning that a and b and c are numbers. It's like we had for bell work. When graphed, quadratic equations make parabolas like this one. When solving a quadratic equation, we solve for x, which represents the x-intercepts, the zeros, the roots, the x's, and solutions. We just talked about that. So the zero product property means that you set your parentheses equal to 0 and you solve for x. Okay? So example number 2. Still in the box right there. Oh, it says equals 10. It doesn't even say equals 0. What do I do? Subtract the 10. Move the 10 over so that everything is together. Now, I need to think of two numbers that multiply to make a 10 but add up to a 3.
5 and 2.
So it's going to be 5 and 2, but your job is to figure out how does the plus and minuses, because I need a negative 3 when I add them. You know, like this has to be something and this has to make a negative 3. Very good. So, what are my two solutions? Just change the signs, guys. Those are my x-intercepts if I had to graph this, but I'm not going to graph it quite yet. We'll get there. All right, so now we're going through and we're going to do these examples together, and you're just going to find the two answers for x. Sometimes there may only be one answer for x. You'll never get 3 answers, though. So set them equal to 0. And isolate the variable. Get x alone. Add 4, divide by 7. Okay, weird numbers. So that means that my parabola would hit like in between numbers, in between 0 and negative 1, and 4/7 would. So you're done. At this point, this is all we're doing today.
Yeah, but like,
if you had to graph it, you just like move over, like not even all the way to negative 1. You'd move over just like negative 1/4, just a little teeny bit to the left. So, easy, right? That's the extent of what I'm asking you to do today. And on number 2, you also have to set the 4 equal to 0. But 4 equal to 0 is like, not, you can't even get an answer out of that. So, I got x equals 3. I got x equals 2. Those are my x-intercepts, my roots, my solutions, my... Okay, number 3. Hey, when 0 is on the numerator in like a division problem like this, is my answer 0 or is my answer undefined?
undefined.
Oh, I don't know.
0.
I don't know.
No, it's 0. 0.
You guys don't remember my fun little saying?
No.
Oh, you have Miss Cortina's when I talk. When 0 is under, it's undefined.
Oh.
When 0 is under, it's undefined. So this is not undefined. Just saying. What is it? Okay. And what's this one right here? Yep. Sweet. We're done. That's it. Keep trucking along, guys. Now I have to actually do some factoring. What? 1 and 1. What do I want to do? 2 and 3 or 6 and 1?
2 and 3.
Okay. I want to make a... Okay, wait. I want this to add up somehow to be a positive 1, though. How are my signs going to be?
3 is going to be positive, 2 is going to be negative.
Negative 2. So that means that this 2 is negative up there. There's my factored trinomial. Okay? Are we good? Oh, 5. What do I do first? It's not a trinomial, so is it grouping? Is it GCF? What is this? Oh, there's something in common? What do they both have? What? X. Factor it out. Now, set them both equal to 0. And you're done. Okay, number 6. Wow. Well, this is very interesting because I need to all of a sudden make a negative 3 out of this. They're both what?
You have to make both ones negative.
Oh. Okay. You're right. So, easy. X equals positive 1. X equals positive 1/2. Oh, but it's not in perfect form for me, darn it. Such a bummer. What do I have to do first? Add 8. Which number do I add 8 to? The 3, the 18?
18.
You're right, because they're like terms. 10. Okay, now I'm... Oh, wait, didn't I have this one on the front side? Was it the exact same... It's 5 and 2, but what kind of signs? I want a positive 3. So the bigger number needs to be positive. Good. Set them both equal to 0. X equals positive 2 and x equals negative 5. On number 8, I'm first going to add 4. 14. How is 14 made? Ooh, 7 plus 2 make 9. Is this easy for you? Number 9 gets more difficult. I had a student have the nerve to say that number 9 was non-factorable. Blasphemy. No, it's factorable. You just have to not give up.
Blasphemy. I haven't heard that word.
It's not really a word you hear people walking around saying, that's blasphemy. Okay, I added 3 to both sides. Now I need to play around. And literally you are like really playing around. 24. There's so much. I mean, 6 times 4, 12 times 2, 8 times 3, 24 times 1. Wait, let me do some mistakes first. Because you're not going to get it right away. And just because he raised his hand doesn't mean, does 12 and 2 make...
Right, 6 and 4.
Oh, it's 6 times 4? Duh. I'm so dumb. What should I say instead? I'm learning. I made a mistake. And that's fine. I'm not going to feel bad about myself. Oh, nope, that's not going to be it. I want to make 19. How about, wait. I can put the 4 on top and I can put the 6 on the bottom.
No. Don't try.
Don't even try. I could do
I'm gonna go with the
12 times, no, 12 times 2? How do I make it a negative, or what I do wrong? Look at all my mistakes. I make so many mistakes, I'm bad at math.
No, you're not. You
What should I say instead?
trying.
My mom?
Just find the ball.
Okay,
Find the ball.
mom? Any mom can help? Okay, so, you guys are getting really good at this, changing your mindset. Equals 0, because I'm not quite finished. By the way, I'm gonna get, 3 halves, but I can't have an x-intercept of 3 halves. Where would you even know to go? How would I do 3 halves of my x-intercept? A mixed number, what's that?
1.
Sweet. Because improper fractions don't work when I'm trying to find x-intercepts or solutions or, okay. This one doesn't work? Who said that? Oh. Wow. 1 and 5. I would want to make 5 plus 6 be 11. So I'm going to do this. Because 5 and 6 make 11. They all have to be positive, I believe. Okay. Are you good with this? X equals negative 1. Subtract 6, divide by 5. Yeah? I don't really like negative 6/5. It's a improper, yeah.
Okay, you do 2 and 3.
10 and 3 make 13, or
Just kidding,
15.
no.
Okay. No, but you have to try, because you're not, if you're not sure, test it out and see. Okay? Get the trinomial, get the quadratic alone on the left. And then, someone also had an issue with number 11 last period.
Factorable.
No, they are all factorable, I'm telling you right now. Okay, well, 2 and 2 and 3 times 5? 10 plus 6, so close, but no cigar. 2 and 2 and 5 and 3. Nope. I need to make 17. 15 and 1?
No, 5 and 3 and 4 and 1.
4 and 1.
Yeah.
3 times 5? Oh, 20 and 3 make 17?
Okay.
That won't work.
Why won't it work?
You would have to have a negative.
I'd have to have a negative 3, and how am I going to get a negative 3 when I'm supposed to have a positive 15? No, I can't make them both negative, because then I'd have...
On the bottom.
But you know what? Someone's going to do that. Someone's legitimately going to do this right now.
Just stay on the bottom.
What?
And be like, oh, look. But here's the problem though.
Wow.
It doesn't make a negative, this makes a negative 15. I want a positive 15.
I think you're talking about 5.
That's 5 on the top and 3 on the bottom.
What?
5 on the top, 3 on the bottom. That's like good math.
Woo!
That is good.
We don't give up.
Doesn't it work?
Yeah, because can't you do like, there you go.
No, that's 4. I have to have a 12 and a 5. I can't do 20 and 3.
But what if you make a positive negative? What if you make a 3 or negative?
Because then it wouldn't come up to,
Because there's no negatives in my math problem at all. So I can't have any negatives in my math.
I feel how do you make this stuff?
If at first you don't succeed, try again. Negative 5/4, negative 3. Okay? Whoa, look at the time. So fun. Time is flying. All right. We need to stop.
weird.